Okay, we're going to begin still in our other textbook, chapter 5, section 3. We're going to do more with trig functions. Okay, first little bit of this lesson, you guys have absolutely seen this before in geometry. SOHCAHTOA, right? So you guys have done this with right triangles since geometry. Sine is the opposite over hypotenuse, right? So this represents right triangles, right? So if I have an angle theta, this is my opposite side, this is my adjacent side, and the side across from the right angle is the hypotenuse. And the trig ratios, as described in or using these opposite, adjacent, hypotenuse, sine is the opposite over the hypotenuse, and that would make cosecant the hypotenuse over the opposite. All right. Cosine is the adjacent over the hypotenuse. All right, and that would make the secant the hypotenuse over the adjacent. All right, tangent is opposite over adjacent, and that would make cotangent adjacent over opposite. All right, so this is stuff that you guys have seen before. I'll kind of quickly go through this first little bit just because I feel like there's no point in going in super detail, right? But I'll do the next example and you'll see what's going on. All right, so we want to find the 6 trig functions of this particular right triangle. All right, so before in these lessons, we've only been dealing with angles in the coordinate plane. This is just any right triangle. And you're going to see why this first little bit is important when we go to the next or later parts of this lesson. Let's just say this is our angle theta, right? It's not labeled, but let's just say this is our angle theta. That makes this over here our opposite. This right here, right next to it, we call this the adjacent. And then across the right angle is our hypotenuse, all right? So to find the hypotenuse, you guys use Pythagorean theorem, a squared plus b squared equals c squared. And then A and B were the legs of our right triangle. And our legs here are 24 and 7. So I'm going to do 7 squared plus 24 squared equals c squared. And so we end up with 49 plus 576 equals c squared. And then you end up with 625 equals c squared. All right, when you square root this is actually a perfect square. We get c is 25. All right. Another way that you can think about it is this is a Pythagorean triple. All right, so you guys learned about these in geometry. So in geometry, when you talked about right triangles and using Pythagorean theorem, anytime that you got perfect whole numbers out of doing Pythagorean theorem, we call those a Pythagorean triple, right? Some common ones are 3, 4, 5 triangles, 6, 8, 10. This one that we just did, 7, 24, 25. Another one is 8, 15, 17, 5, 12, 13, right? So these are some that are going to come up a lot. And it just means that the longest side is going to be the hypotenuse. The 2 shorter ones, or the 2 smaller values, are going to be the legs of your right triangle. But let's find the 6 trig functions using, using the opposite as 24, the adjacent as 7, and the hypotenuse as 25, all right? So that I know that sine of this angle has to be the opposite over hypotenuse, so 24 over 25. All right, cosine has to be the adjacent over hypotenuse, so 7 over 25. And the tangent has to be opposite over adjacent, so 24 over 7. All right, and I also know that cosecant, I'm just going to flip that angle and it's going to be, or that value, and it's going to be 25 over 24. I know that the secant of that angle is going to be 25 over 7. And the cotangent of this angle is going to be 7 over 24. All right. So that part's not new, right? You guys know, 1, how to find the 6 trig values, and 2, how to use SOHCAHTOA and Pythagorean theorem to evaluate trig ratios. All right, so that part's not new. It's going to help us in the later part of this lesson, and you'll see. Okay, I'm not going to go over this example just because these numbers are going to be important in the next page and the page after. And I'm going to guess that you guys know how to use SOHCAHTOA to figure out the trig functions of a right triangle, right? So I'm just going to go ahead and skip over this. All right, this is super important stuff. You guys have also for sure seen this before. This is kind of going to be the backbone of the later lessons that we do in evaluating trig functions of any angle, all right? So it's going to lay the foundation for when we do unit circle, right? So I'm sure you guys have maybe heard of the unit circle at some point, right? This is really going to lay the foundation for that. But there are 2 types of special right triangles. The first kind is a 45-45-90. I'll talk about that one first. All right, so a 45-45-90 just means the 2 acute angles of a right triangle are both 45 degrees. You might also see this as an isosceles right triangle, so meaning that 2 opposite angles are congruent, and these 2 legs are congruent. All right. We have in this little image right here that the 2 legs are 1 and the hypotenuse is the square root of 2. This can actually be generalized to any length, right, of any leg. So let's just say this one is A. That would make this leg also A, and that would make the hypotenuse A times the square root of 2. All right. So for instance, if I gave you like a triangle and it was a 45-45-90 and this one's 8, then that would make this side 8 and that would make this side 8 times the square root of 2. All right. Similarly, if I gave you the hypotenuse, you could set the hypotenuse equal to a square root of 2 to kind of figure out what the legs are, right? So that's stuff that you guys learned in geometry. I'm not going to go over that too much. Let's talk about the same thing with a 30-60-90 triangle. All right, so 30, 60, 90. All right, that's this triangle. 30 degrees is the smaller acute angle, and it's going to correspond with the shorter leg. All right, and in this case, in this image, the shorter leg has a length of 1. The longer leg is going to be across the 60 degrees, right? That's our bigger acute angle in this right triangle, which is the square root of 3 in this image. And then across the right angle is our hypotenuse, and in this image it's 2. But again, just like the 45-45-90, it can be generalized to leg lengths of any measurement, right? So this is going to be A, the shorter leg. The longer leg is going to be A times the square root of 3. And then our hypotenuse is going to be 2 times A. So again, similarly, let's say I give you one part of this 30, 60, 90 triangle. Let's say I gave you that the hypotenuse is 12. Then you can get that 12 is 2A. So that would make the shortest leg A of 6. And that would make the longer leg 6 times the square root of 3. All right, so that sort of thing that you guys have learned in geometry. But you guys are going to see why this is important in the next few problems. All right, so this first page, we're going to evaluate the 6 trig functions at both 30 degrees and 60 degrees. All right, so why are those measurements important? Because they correspond to the measurements inside of a 30, 60, 90 triangle. So I'm going to draw this out. I'm going to draw the 30, 60, 90 triangle that you guys are very familiar with. All right, so I'm going to draw this right triangle. And then I have that the shorter angle is 30, the bigger one is 60 degrees. And then I know that across the 30 is a measurement of A. Across the 60 is A square root of 3. And then across the 90 degrees, the hypotenuse is 2A. All right, So just by having these measurements, we don't even need to have a number in for A. It can be really anything. Just by having this triangle labeled already, I can use SOHCAHTOA to figure out sine, cosine, tangent of 30 degrees. All right. Now, 30 degrees, that would make that this is our angle theta, and that would make the side across from this A, which is our opposite. So when theta is 30 degrees, I have that the opposite is A. All right. So, whoa, hang on, my screen just went crazy for a second there. Hold on. Okay, so opposite is A. My adjacent side is going to be this right next to it, and then I have the adjacent is A times the square root of 3. And then I have the hypotenuse now is 2A. 2A. I'm going to use A square root 3, and 2A in our SOHCAHTOA to try to figure out the trig functions of these angles, right? So at 30 degrees, I know that sine is opposite over hypotenuse. So that would make the opposite A and our hypotenuse 2A, right? Simplifying this, the A's are going to cancel out, and this is going to become 1/2. So then I have sine at 30 degrees is 1/2. That would make cosecant of 30 2A over A, which the A's cancel out again, and this is just going to get you 2. All right? We can do the same thing for cosine, right? I have that cosine is adjacent over hypotenuse, and we labeled our adjacent side as A times the square root of 3. So A square root of 3 over A, over 2A, right? Our hypotenuse is 2A. And then once again, our A's cancel out, and so this is going to get us the square root of 3 over 2. All right? And that would make secant the reciprocal, right? So it's going to be 2A over A square root of 3. Our A's cancel out. This is going to get us 2 over the square root of 3. I'm going to rationalize it, so times the square root of 3 top and bottom. And so we're going to get 2 square root of 3 over 3. And so that's the secant of 30 degrees. This is the exact value. Exact same thing for tangent. I'm going to do opposite over adjacent. And the opposite in this case was A. The adjacent was A square root of 3. So A over A square root of 3. These are going to cancel out, and so we're going to get 1 over the square root of 3, which I can rationalize, right? And this is going to become the square root of 3 over 3. And so that's our tangent of 30 degrees. All right, and then to find our cotangent at 30 degrees, I'm just going to take the reciprocal. So this is going to be A square root of 3 over A. All right, so opposite over adjacent. Adjacent over opposite. And so we're going to cross out our A's, and this is going to get us the square root of 3. And so cotangent of 30 degrees is just the square root of 3. So just by using these right triangles, we didn't even need accurate measurements. We just needed that the sides were labeled correctly, right? The A square root of 3, and 2A, to be able to get exact values, right? It doesn't matter the value of A. It doesn't matter what it is, all right? And now I can use this exact same triangle to try to find the 6 trig functions of 60 degrees. So again, I'm going to use SOHCAHTOA to try to figure that out. In this case, my angle theta is the 60 degrees. So that means my opposite is going to be A square root of 3. So they kind of flip, right? So the opposite is A square root of 3. The adjacent is A. And then the hypotenuse is 2A. All right? So then sine, once again, is opposite over hypotenuse. So this one's going to be A square root of 3 over 2A. And then the A's are going to cancel out, and so you get the square root of 3 over 2. And so that's sine of 60 degrees. Cosine of 60 degrees is adjacent over hypotenuse. So this is going to be A over 2A. Once again, the A's cancel out, and so we're left with a half. All right? And then tangent, opposite over adjacent, is going to be A square root of 3 over a. And then our a's are going to cancel out, and then we're just going to be left with the square root of 3. And then to find our reciprocal identities, we're just going to, of course, take the reciprocal. So this one's going to be 2a over a square root of 3. Our a's cancel out, and then I can multiply the top and the bottom by the square root of 3. So we end up with 2 square root of 3 over 3. All right. Secant of 60, I'm going to take the reciprocal of cosine, so it's going to be 2a over a. A's cancel out, and so I get secant of 60 is 2. All right. Cotangent of 60 is going to be a over a square root of 3. So the reciprocal of tangent. Cross out the a's, and then we get square root of 3 top and bottom. And so this is the square root of 3 over 3. All right. And yeah, that's it for this slide, right? So that's how we used a 30, 60, 90 triangle to find our 6 trig functions. And we're going to do the same thing in the next slide. All right, so you're going to see in this slide, we see 45-degree angles, right? So 45-degree angles, I would draw a little right triangle here to get that 45, 45, 90 triangle. All right, so again, it's an isosceles right triangle. This is the right angle, and I know that it's going to be a, and then a squared of 2. All right, it doesn't matter which angle I use for theta, right? I'm just going to say it's this one right here, right? Just because a and a are exactly the same, right? So my opposite is going to be a, my adjacent is going to be a, and then the hypotenuse is a squared of 2. So again, just like in the previous slide, let's use SOHCAHTOA to figure out our 6 trig functions of 45 degrees. All right, so then at 45, it's going to be opposite over hypotenuse, so a squared of 2. A's cancel out, and then I'm going to rationalize. And so this is going to get us the square root of 2 over 2. All right, to find the cosecant, I'm just going to take the reciprocal, so it's going to be a square root of 2 over a, which simplifies to the square root of 2. All right, cosine of 45, you're going to notice, is a over a square root of 2, which is exactly what we just got for sine. So I know after rationalizing, this is going to get us the square root of 2 over 2. All right, now secant would then, of course, give you the exact same answer as cosecant, right? This is going to get you the square root of 2. All right, if you flip cosine, you're going to get that same value. All right, now if I did tangent, opposite over adjacent, I just get a over a, which is 1. All right, and if I did cotangent, that's also going to get you a over a, which is also 1. All right, so we were able to very easily get our 6 trig values of 45 degrees. All right, so it's good that we did that with those, because that's going to kind of lay the groundwork for how we're going to solve the rest of these examples in these notes. Okay, so now we get into something called a reference angle. I'll start by saying that a reference angle is just the acute angle that is the distance between the terminal side of any angle and the x-axis. All right, so acute meaning it has to be less than 90 degrees. All right, and between that angle, whatever angle you're given, and the x-axis. All right, so you're going to see why reference angles are important. They're going to help us evaluate something like, for example, sine of 150. All right, we're going to be able to solve or evaluate something like that without a calculator. All right, now we can only do that if we know what a reference angle is, right? So I'll just use this slide to explain what it is, and then I'll explain why it's useful. All right, so in the first quadrant, the reference angle is just the angle itself. So if I had, let's just say, this angle right here, that already is an acute angle, and it already is the distance between the x-axis and the terminal side, right? So that already is our reference angle. Now, in the second quadrant, we can find a reference angle by doing 180 minus whatever angle we have. So if I have this angle right here, all right, I can find this reference angle as in this acute angle right here, right? So this is the reference angle. I can find that distance by doing 180 minus whatever angle this is, right? So right here. All right, and the reason that works just because a straight line, as you guys know, is 180 degrees. And so that would make this little angle plus this little angle 180 degrees. All right, this is a straight line. All right, so we are always going to do 180 minus that angle. In the third quadrant, what we can do is, again, let's just say I have an angle like this and I go all the way around right here. To find this acute angle right here, so this little acute angle, all right, it's going to be whatever angle we have minus 180. All right, think about a straight line again, right? If I get rid of this straight line, you're only going to be left with this little piece left. All right, so we're going to do that angle minus 180. So take away a straight line, and then we get the angle that we are looking for. All right. And then lastly, in the fourth quadrant, right, let's just say I have an angle right here, and you loop all the way around, right? And then we get this as our angle. The reference angle is going to be 360 minus the angle that we have. Just because this right here is going to be our reference angle, so that little angle right here. And if I were to add this little angle and this whole angle, you get a full rotation of 360 degrees. All right, so in the fourth quadrant, it's always 360 minus the angle. All right. Reference angles are important just because in the previous slides we talked about special right triangles, the 45, 45, 90, and the 30, 60, 90. What we're going to be able to do with reference angles is we're going to be able to evaluate trig functions at almost any angle, right? Any angle in this lesson is going to involve our special right triangle some way, shape, or form, all right? And you're going to see what I mean in the next slide. Okay, let's evaluate these trig functions using reference angles, all right? So I'm going to take first sine of 210. The first thing I want to do is kind of sketch out where this is going to be, right? So I know 210 has to be in the third quadrant, right? Because I know this is 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees, all right? So I know that 210 has to be somewhere right there. All right, so I'm going to say that this is 210 degrees. All right. Where the reference angle is useful is I can construct a right triangle using this little angle right here and connecting this at some point to the x-axis, right? So we get a little right triangle here. Now, we've only worked so far with 30, 60, 90, and 45, 45, 90. So if I can find a reference angle that does relate to one of those triangles, then that's going to make this problem super easy. All right, so in the third quadrant, all right, 210, to find a reference angle, I'm going to subtract 180. All right, and then we're left with 30. All right, now this angle actually does have meaning to us because I know that the side opposite of a 30-degree angle is A. Right, this is the 60 degrees. I know that this is a square root of 3, and then I know that the hypotenuse is 2a. Right, so it looks something like this. We have a little right triangle. All right, now sine, I know, is opposite over hypotenuse. All right, and our angle of interest right here is this 30 degrees. So I'm going to take the opposite, which is a. So I'm going to say that this is a over the hypotenuse, which is 2a. So a over 2a, which is going to get you 1/2. All right. Now what you have to do is you need to figure out the sign of this number, right? Is it a positive 1/2 or is it a negative? And to do that, you're just going to use all students take calculus to figure out what quadrant, the sign of sine in the third quadrant, right? So in the third quadrant, I have tangent and cotangent are positive. Everything else is negative, so this is going to be a negative 1/2. All right, and that's really the gist of these kinds of problems, right? So I'll show you how to do the next one as well. All right, so if I have a tangent of 300, again, the first thing I want to do is kind of sketch out what this would look like. And 300 is between 270 and 360. So I know that this for sure has to be in the fourth quadrant. All right, so it's going to be something like that. Now I want to find the reference angle to construct a special right triangle. All right, to find the reference angle in the fourth quadrant, it's going to be 360 minus our angle, which is going to be 60 degrees. All right, so I have 60 degrees right here. And so we can make a little right triangle, and I know that this is going to be 30 degrees, so I can label the sides now. This is going to be a square root of 3, and 2a. Tangent, I know, is opposite over adjacent. The opposite of the 60 degrees is a square root of 3, and the adjacent is a. Now this simplifies to just the square root of 3. And again, use all students take calculus to figure out what the sign of tangent is going to be. All right, and in the fourth quadrant, it's just cosine and it's reciprocal. That means this is going to be a negative square root of 3. All right, let's try the same thing with this one. If you have an angle that's pretty big, right, we can't really do the same thing that we could in the other two problems. What you can do is you can find a coterminal angle, right? So to find a coterminal angle, we typically only like to work in the 0 to 360 range. So let's see what we can do, right? If we subtract 360 from 675, we get tangent of 315. These two angles are coterminal, meaning that tangent of 315 is going to be the exact same thing as tangent of 675. All right, so let's try tangent of 315, right? Let's see what that gets us. Again, that's going to be in the fourth quadrant, so I know it's going to be something like that. Now to find this acute angle right here, right, we're going to do 360 minus 315, and that's going to get us 45 degrees. So I know that this is 45, and then I can draw a little right triangle. This is also 45, so then I know that this is a, and a square root of 2. All right, now I can use SOHCAHTOA, right? Opposite over adjacent is just going to be a over a, which is just 1. All right, now in the fourth quadrant, again, use all students take calculus, and I know that this is going to be a negative 1. All right. We can try the exact same thing with the next one. All right, so negative 240. Again, we like to work in the 0 to 360 range, so I'm going to add 360 to this, and this is going to be cosine of 120. All right, so cosine of negative 240 and cosine of 120 are going to get you the exact same things. All right, so let's sketch this out. I know that 120 has to be in the second quadrant. And to find a reference angle in the second quadrant, it's going to be 180 minus our angle, which is 60 degrees. So I know this angle right here is 60. I can sketch a right triangle. This is going to be 30. So I know that this is going to be a square root of 3, and 2a. Cosine is adjacent over hypotenuse, and the adjacent of 60 is a. The hypotenuse is 2a. So we get a over 2a, and that simplifies to 1/2. Again, use all students take calculus. And I know that in the second quadrant, sine and cosecant are positive, so everything else is negative. This would be a negative 1/2. All right. Shouldn't be too bad, right? A lot of it is just relating the right triangle stuff to finding values at bigger angles, right, or different angles. So you can try the same thing over here. All right, this one's a little bit different just because it's not sine, cosine, or tangent. This one's going to be a secant, right? So what you need to do is figure out what secant goes with, right? And we know that it goes with cosine. So let's think about cosine, right? I need an adjacent and a hypotenuse, so that means secant is also going to need an adjacent and a hypotenuse. All right, so let's sketch this out. Let's keep that information in mind, right? I know that this is going to be in the third quadrant. And in the third quadrant, it's going to be our angle minus 180. So then we get 30 degrees. So this angle right here is 30 degrees. I can draw a little triangle. And then I have a right angle right here, 60 right here. So then this is going to be a square root of 3, and 2a. All right, so I know that cosine is adjacent over hypotenuse. And the adjacent of 30 degrees is a square root of 3. and then the hypotenuse is 2a, so then this is square root of 3 over 2. That means the secant is just going to be the reciprocal of this. It's going to be 2 over the square root of 3, and then you can rationalize, all right? So after you rationalize, we get 2 square root of 3 over 3. And then in the third quadrant, right, tangent and cotangent are positive, right? So that means everything else is negative. This is going to be a negative 2 square root of 3 over 3, all right? Let's try the same thing over here. Cotangent, I know, is the reciprocal of tangent, right? So that should help us out a little bit, right? 135 is in the second quadrant, so that means my reference angle is going to be 180 minus 135, and then so we get 45. So this is a 45, 45, 90 triangle, all right? So that means I know that this is going to be A, and A square root of 2. And with tangent, I know that tangent of 135 has to be the opposite over the adjacent, so A over A, which is 1. So that means cotangent is just the reciprocal of 1, which is just 1. All right, and in the second quadrant, tangent is negative, so this should be a negative 1. All right, let's try the same thing here with cosecant. All right, cosecant I know goes with secant of 210. So again, let's just keep that in mind. I know that this is in the third quadrant, all right? So this is going to be 210 minus 180. So then we get 30 degrees, all right? So then this angle right here has to be 30 degrees. And then we get a little right triangle. So then we get 30, 60, and 90. So this is going to be A square root of 3 and 2a. And then I know that, whoa, I did this wrong. Hold on. Sorry, that should be sine of 210. Sorry. All right. So I know that sine is opposite over hypotenuse. So this is going to be A over 2a, which simplifies to 1/2. So that means the reciprocal cosecant is just going to be 2. All right. And in the third quadrant, I still have that it's negative. All right. So we got a lot of negative answers here. All right. Now with sine of negative 510, all right, once again, we're going to need to find a coterminal angle. So I'm going to add 360. So then we get sine of, what's this going to be, negative 150. Again, don't quite know what that is, so let's add 360 again. And that should get us sine of 210, all right? Once again, right, we've done 210 a bunch. We actually just did it in this previous problem, and we found that it was 1/2, right? So I'm just going to use that fact for this problem. If you didn't know that, you would draw the triangle and do it from scratch, right? But we kind of already did it, so let's just use that to our advantage, right? So this is going to be 1/2, and in the third quadrant, sine is negative. So I have that this is negative 1/2, all right? And I can do the same thing with tangent, right? If I have 1020, again, just keep adding 360 until you get a number that makes sense to you, right? So then if we add 360, we get negative 660. Again, don't quite know what to do with that, so let's add 360 again. All right, let's see what that gets us. That's going to get us negative 300. So let's add 360 again. And then what we end up with is just 60, all right? So this is a case where the reference angle is in the first quadrant, all right? So 60 degrees, I already know that that's this angle right here. I don't have to do any math to find the reference angle. It's just going to be 60, all right? So then I know that this is going to be a 30, 60, 90 triangle. So A square root of 3 and 2a, and tangent is opposite over adjacent. So this is going to be A square root of 3 over a, which simplifies to just the square root of 3. And in the first quadrant, all of the trig functions are positive. So I know that this is a positive square root of 3. All right. But that's how you do those kinds of problems, right? You're always going to find a reference angle, draw your right triangle, use SOHCAHTOA to figure out the rest. All right, so now we're going to kind of work backwards, right? So this time we're given what the trig function is equal to, and what we're looking for is the angle, all right? And we're specifically finding the angle between the numbers 0 and 360. Again, that bracket means you can include 0. That parentheses means you cannot include 360. All right, so between 0 and 360, 0 can be an answer, 360 cannot. We just need answers between those two numbers, all right? Now, with these kinds of problems, again, you're working backwards. So you're going to look at what you have as your trig function. So in this case, it's the square root of 2 over 2, negative. And I know it's a cosine, so I know that this has to be the adjacent over the hypotenuse, which might help us a little bit, but the biggest thing that we can keep in mind is that these are always going to relate to special right triangles. So I know that it's either going to be a 45, 45, 90, so a square root of 2, or a 30, 60, 90, right? So a square root of 3, and 2a. So you're going to look at your two triangles, and you're going to decide which one has a square root of 2, right? And that's going to be a 45, 45, 90. So that means I know my reference angle is 45 degrees. All right, now you just have to decide what quadrants we're in, right? Now you can use all students take calculus to figure out where cosine is negative, right? Cosine would be negative in the second and the third quadrant, all right? So what I'm going to do is I need to figure out the angle that has 45 degrees as a reference angle in the second and third quadrant, all right? So that means I need to find this angle, right? So I know that this has to be 45, and I need to find this angle, right? I know that this also has to be 45 degrees, all right? To find that red angle, what we can do is we're going to do 180 minus 45. That's going to get us 135, all right? Why did I do 180 minus? Well, because this whole line right here is 180 degrees, and if I want to go backwards 45, then I'm going to have to subtract it to get whatever's left over. All right, so then I have one of my answers for theta is 135 degrees. All right, now to get that blue angle, think about it the same way. I have a straight line, all right, that's 180 degrees, and then if I go 45 degrees more, I'm just adding 45 to that angle. So this is going to be 180 plus 45, and that's going to get you 225. So my other possible answer is 225 degrees, right? You need to list both answers, right? These are all going to either have 2 answers or some of them have 4 answers, right? But you're never just going to list one of them, all right? Now, let's try that same logic with this one. All right, so let's look at this one. I have cosine equals negative square root of 3 over 2. You're going to think about your special right triangles, which one has a square root of 3, all right? And that is a 30, 60, 90, right? So I know for sure that I'm going to have a 30, 60, 90, either a 30 degrees or a 60 degrees as my reference angle. So let's just figure out which one. So I have a 30, a 60, and a 90, a square root of 3, and 2a. So between 60 and 30, which one has a square root of 3 as an adjacent, right? Because cosine is adjacent over hypotenuse. And that's going to be the 30 degrees, right? This a square root of 3 is our adjacent. So that means I know that 30 degrees has to be my reference angle. All right? So let's just figure out which quadrants we're in now, right? Again, cosine is negative. You can use all students take calculus and figure out that in the second and third quadrants, cosine is negative, right? So we're going to do the same thing that we did in the previous problem. I'm going to kind of sketch it out just so that we can see, right? So I know that for sure I'm going to need this angle right here, which is 30 degrees, and then I need this angle right here, which is also 30 degrees. So again, in this second quadrant, what we're going to do is we're going to do 180 minus that 30 degrees, which is 150, all right? So I know for sure one of my answers for theta is 150 degrees. Now to get that answer in the third quadrant, I'm going to do 180 plus 30, and that's going to get you 210. So theta is 210 degrees. And these are my two answers. All right, again, I'm adding just because in the third quadrant we have a straight line plus a little more, right? And that little more is 30 degrees. All right, let's try the same thing with tangent. All right, so the tangent ones can be a little bit tricky, right? Sometimes the sine and cosine ones can be a little bit more straightforward. The tangent ones can be a little tricky. I'll show you why. Just because we can still kind of do the same thing, right? I see a square root of 3, so I know for sure it has to be a 30, 60, 90 triangle. All right, so I know for sure it's going to be a 30, 60, and a 90. So a square root of 3, and 2a. Now, the tricky thing here is both the opposite and the adjacent are going to get you a square root of 3. And notice, if you look at number 18 as well, that one also has a square root of 3, but it looks a little different than the one in number 16. All right, so you just need to figure out whether it's the 30 degrees or the 60 degrees that's your reference angle. So let's try 30 degrees. 30 degrees, it's going to be opposite, which is a, over the adjacent, which is a square root of 3. And that's going to simplify to 1 over square root of 3. And when we rationalize that, that's going to get you the square root of 3 over 3, which is not the one in number 16, but it is the one in number 18. So that means in number 18, I know that that reference angle is 30 degrees, all right? But for number 16, that would make our reference angle 60 degrees, all right? And I'll explain why, right? The opposite in this case for 60 degrees is a square root of 3, and the adjacent is this a. A square root of 3 over a simplifies to the square root of 3, and that is what we have in number 16, all right? So we're going to use 60 degrees in number 16 and 30 degrees in number 18, all right? Now, once again, tangent is negative. You have to pay attention to the sign. So I know that tangent is negative in the second and the fourth quadrant, right? All students take calculus. All and tangent are going to be positive. Everything else is negative, all right? So let's sketch this out. I know that the 60 degrees in the first quadrant is just going to be 60 degrees, right? You don't need to do anything to it. So theta, one of my answers is 60 degrees. And I just realized I'm doing it wrong. Sorry, let me get rid of that. All right, I checked off the right ones, but I didn't write the right ones, right? So I'm looking in the second and the fourth quadrant. My bad, guys. I'm sorry. All right, so in the second quadrant, it's going to be this bit, right? So that's going to be 60 degrees. And then in the fourth quadrant, I have that bit's going to be 60 degrees. All right, in the second quadrant, to find our actual angle given the reference, it's going to be 180 minus 60, which is 120, all right? So I get theta is actually 120, all right? Sorry about that, all right? And in the fourth quadrant, right, we can do a full rotation, take away the 60 degrees, and that's how we get our actual angle. A full rotation is 360. If we take away 60, that's going to get us 300. So I know theta has to be 300 degrees. All right. So then that's our answer for number 16. All right, let's try number 18, right? Now that we already know what the angle is going to be, we know that it's going to be 30 degrees. Let's try 18. All right, this one's going to be positive. So this one is actually going to be, all students take calculus. We're going to be in the first and the third. All right. In the first quadrant, the reference angle is just the angle. Right, I don't need to do anything to it. So I know for sure one of my answers for theta is 30 degrees. In the third quadrant, it's going to be 180 plus our reference angle is 210, right? We go 180 plus a little more, right? So our theta is going to be 210 degrees. So we get that as our answer, all right? Now, let's finish up. Let's try 17, right? Notice that in number 17, I have a plus minus. And cosecant goes with sine. So that means sine can either be positive or negative, right? Think about the quadrants in which sine is either positive or negative, right? That's actually all the quadrants, right? Every single quadrant has a positive or a negative for sine, right? Now let's decide which triangle we're going to use. Again, I have a square root of 3. So that's an indication that you're going to use a 30, 60, 90 triangle, all right? So 30, 60, 90, all right? I'm always going to draw the triangles, right? That's always going to help you out in these kinds of problems, all right? Now, square root of 3 shows up. That means that's going to need to be somewhere in our sine ratio, right? So between the 60 and the 30, only one of them is going to have a square root of 3 show up in the answer. And that's a 60 degree, right? Because the opposite of 60 degrees is a square root of 3. So that means our reference angle is 60. I'm going to draw this out. I know that in the first quadrant, that reference angle is just going to be the 60 degrees. I don't need to do anything to it. All right. In the second quadrant, my reference angle is 60. To find that, it's going to be 180 minus 60. So 120. So I know that my theta has to be 120 degrees. In the third quadrant, it's going to be 180 plus 60. So we get 240. And then in the fourth quadrant, it's going to be 360 minus 60. All right, so 300. So that means my last answer, theta, is 300 degrees. All right, so then we get 4 answers for those. All right, but that's in general how you would do these problems. Notice in all of them, I drew the right triangle and I labeled the sides. And then from there, you have to decide using SOHCAHTOA which angle is going to be your reference angle, right? So it shouldn't be too bad, right? You might just need to be a little bit careful with your work, but again, shouldn't be too bad.